Okay, we start with our lecture. Let's invite our students too. Hmm. Hmm. Selamlar.
Merhaba hocam.
Dün bir sunum yaptığım için İTÜ arka planı kalmış. Bunu hemen değiştireyim. Ondan sonra başka üniversitenin reklamı yapılıyor olmasın. Şöyle şuraya gidelim. Yok bu daha iyi. Yine katılmaz ya. Cumartesi üçlüsü ile devam ediyoruz. Bu derse bayağı önemsiyordum aslında. Neyse. Okay, we are going to talk about game engines in general, and we will also talk about the benefits of choosing and using Unity 3D engine as our selection. By the way, I'm informed that my connection is unstable, so if you have any trouble, just write me from WhatsApp or chat, so I can change my network settings. And yeah, after that, we are going to actually see how to install and download Unity Hub and Unity 3D. And after that, I believe we will have, you know, 30 or 40 minutes to talk about general interface of Unity. Okay, let's start. I'm going to share my screen as usual. Okay, so this is the presentation I found useful, so I didn't edit, but I will add stuff that I feel the need to. Um, so first of all, we are going to talk about what's a game engine. We will talk briefly about engine architecture, and after that we will talk about tools and the asset pipeline a bit. After that we will see different types of game engines and their advantages and disadvantages to some extent, and we will also talk about base rated engines. um, okay, so what is a game engine? A game engine basically is a tool that lets us let us quickly um, create prototypes and games uh, than we would normally make, because they already come equipped with the common tools that are needed for creating a game. We will talk about these common uh, problems in game development, and we will talk about how game engines solve this problem. Uh, Developers use them to create games for consoles, mobile devices, and personal computers. Uh, Not all game engines support all platforms, unfortunately. But luckily, we have chosen Unity 3D, so it won't be a problem for us. And um, it's a term, but it's useful to say it actually. A game engine is a software framework. So a framework basically means what I have described. A framework, actually, since I don't want to confuse you, I will just look up for the dictionary definition. Okay, in computer programming, a software framework is an abstraction in which software providing generic functionality can be selectively changed by additional user-written code, thus providing application-specific software. Okay, this is a yeah, better definition. I would say in practical, when we are talking about frameworks, we say they are already equipped tools that supports our development process. Yeah, but this says it's an abstraction. By abstraction, that means you don't have to go into the details of implementation when you are writing the code. You can describe what you want, and uh, this framework takes care of the thing that you want to do. So, for instance, when you are using low-level languages, you need to take care of memory management, etc. But if you use a high-level framework such as Unity, it's going to take care of, for instance, garbage collection. So, garbage collection, um, for instance, is something you do with C++, right? I'm not sure if you know the term. So you basically release the memory that you ended up using. You know, you release the memory so that other programs can use it at the end of your flow, at the end of your loop. But Unity takes care of those kind of things. So it's, I mean, you don't have to write it every time. And other important thing is it provides generic functionality. So generic functionality means common. It solves common problems that are seen in softwares mostly. That are seen in most softwares, and it can also be edited by user written code. So um, you don't have to um, submit into this framework, but you can adjust it according to your needs. For instance, in Unity, we will be adding additional packages, additional um, sometimes even frameworks from time to time. So we and even in editor, for instance, you can change the sizes of different windows. You can um, change different parameters in the editor, uh, in Unity editor, I mean. So yeah, this is doable. You don't have to be limited by what Unity 3D offers. Okay, so since we covered what is a software framework, let's go back to our presentation. Um, like we said, a game engine is a software framework. Um, it provides some set of tools to assist us, and it's generally game agnostic. So it's not generally popular game engines are not written for one specific kind of game, but they are written for game development in general. Sometimes they are targeting a specific kind of game, which are 2D games or 3D games, but um, they do not um, generally. I mean, they do support more than one games in general. The exception is when a game company decides to increase their game's performance by a lot, and if that's the case, they can decide to um, write some game engine, um, and then develop their game in that game engine. But um, this is an expensive process. uh, Writing a game engine itself is a really hard task. I believe it's harder than writing a game. But there are big companies that do that, and uh, sometimes since there's only one game with written in this game engine, I believe it doesn't count as game agnostic. Yeah. Um and one other thing that we should talk about is components. So components is a word you will hear often, um, and it in different contexts it means different things. Uh, it's here it says a game engine has different uh, parts that you can choose to use or not use. Um, in Unity 3D, uh, the software architecture uses something we call component design pattern. This basically means that to add some functionality to an object, you basically add a component to it. Um, I'm going to give an example from real life, if we can count that in as real life. Um, if you want to swim, you um, buy a pallet. If you want to fly, you buy a jetpack and equip it. And if you want to do both, you equip them both. So this is a, a stupid example, but this is what is actually used by Unity. So it's a different. I mean, here it says uh, components that are like help you to publish games, or components that help you, I don't know, render games, etc. But Unity itself has a component-based structure. So when you're writing codes, even when you want to add a behavior to an a game object, you basically add some component to it. Okay, that's enough for this line. And it says it's reusable for many different games. We talked about that. They are typically multi-platform, according to this slide. Both Unity and Unreal are um, multi-platform. They allow for data-driven development. This is not um, needed for our lecture, and they make development faster. This is why we choose it. Okay, runtime engine architecture. Mm, I'm not sure if this is useful to you. Let me check. Okay, some of them are useful, but it will go into details. So basically, I said that they offer some common solutions to common problems. Um, Before that, actually, I want to ask you what can be those common problems. You already read some of them, but still, uh, I was wondering your. I mean, what when you think about a video game, for instance, let's say I don't know, let's say Counter Strike. Okay, what can be the problems? I mean, you know how to write codes, but obviously you don't know how to write Counter Strike. But what is stopping you from writing Counter Strike? Just think about that. I mean, what are the things that you don't know yet, but would be needed to write Counter Strike?
Well, at first, I think the AI system of Counter Strike, the bots,
Hmm,
I don't have any clue of writing them.
okay. So let's add some details to that. An AI system in Counter Strike basically navigates through the map, right?
Yes,
And they aim at you and shoot you, right? Okay, so the aiming and shooting part can be written by you actually, but do you know how to navigate uh, without touching the walls? You know, uh,
no, I don't know.
this is a this is a common task in most games. Actually, shooting part is a common task for games, and there are some additional tools that help you with shooting. But let's stick with navigating for now. Um, for navigation, for instance, you need to um, know that you shouldn't um, pass through walls or doors. I mean, closed doors. And you also need to walk in a clever way such that you don't um, look back and go back and forth. You know, you need to basically cover the area where you are while you are walking. And there are some algorithms like A star, which helps with finding the best path, shortest path from point A to point B. And you can, of course, implement that. It would take around half a day or 1 day for you to um, implement this algorithm approximately. But um, actually, Unity offers a solution for that. It's called Nav Mesh. So it's navigation mesh. Mesh means in Turkish. Uh, we can maybe talk about this in I don't know, maybe it will show up in our example projects. But okay, what else do we need for? I mean, do you know how to paint something in the screen of the player?
Don't know that either, I think.
Yeah,
And some other big problem is the matching system, the
exactly,
online matching
exactly,
system.
exactly. But in almost all games, there's a matching system and there's a rendering system. Okay, so I don't know. Um, I mean, I know how to create a menu in different languages, in different platforms, such as web, um, Android, or iOS, or also in Unity. But I don't know how to render a, screenshot of a game pixel by pixel. Okay, and this is acceptable. There are people that are working on that part. This is a actually software engineer task that they should find solutions, and they are finding good solutions. This is what companies like Nvidia are focusing on. they are creating, optimum rendering solutions so that we can have a high frame per second. And also in game engines, there are ways that tells the graphics cards where is everything and how graphics cards should draw the screen. Okay, we have talked about some examples. Uh, Actually, it says renderer here on top. And other thing is collision detection. Maybe you see this parts in Godot engine, I'm not sure, but uh, collision detection means that if two different game objects cannot pass through each other, they should not. So there should be a limit to that. Or sometimes, if two objects can pass through each other, then we should also detect this and act accordingly, such as uh, in most games, after you, after, okay, not in most games, but in a basketball game, for instance, if your ball touches the um, basket, then you get a point, right? So for that, you need to detect the collision between um, some place inside the basket and your ball. Um, okay, so this is a common problem, but this is a hard problem, especially in 3D, because I mean, it's easy to detect collisions when all the objects in your scene are spheres, because all you need to do is um, take the center of each sphere, right, and see the distance between spheres, and uh, also, okay, I'm going to draw this actually, since it's, let me just see. What is this? Okay, I'm going to instead um, mm, okay, so this is an example that I can use to tell. So if in an ideal scenario, all the game objects are in primitive shapes, such as cubes or uh, circles. So in this case, in this picture, there are some circles that are obviously collided together. So they are inside each other, intervened. But this one is not. So mathematically, you calculate this situation by calculating the distance between. Can you see my mouse, by the way? Okay, great.
Yes, we can see.
So this dark blue circle um, has a center point, and this pink little circle has also a center point. And if you see um, difference between the um, what was that?
The radius.
No, it's not radius, but the distance. Okay, distance. Yeah, distance between two uh, centers. It's more than the total radius of these two, right? So I mean, this pink circle can have a radius of 1, and this might have a radius of 2, but since the distance between these two centers are more than 3, there's a gap between them. So this is a really simplistic example of collision detection. But um, and if you see this orange and light blue um intersection, obviously the distance between two centers are less than the total radius of two circles. So if Unity does not provide you that, then you need to um, check all those types of collisions between rectangles, between circles, between cylinders, etc. And this is just a simple example from 2D world. It's getting harder to do that in 3D. Luckily, though, we have Unity to help us. Okay, it helps us with scripting. So actually, um, other program uh, other programs help us with scripting. We use them in conjunction with Unity, but um, they Unity helps us with foldering our scripts. So you can see some of your scripts too in Unity, even though it's not uh, possible to edit your scripts while you are in Unity, if you are using default settings, I mean. Okay, and it helps you with playing sound or video. So in most games, there is a looping music. Sometimes this music track changes with changing of levels. Uh, Easily, you can do that in Unity or in most game engines. And animation, and this is another common problem. Some animations can be quite um, easy to describe um, in a software program, such as imagine a swing that is swinging from one point to another. This is uh, something really simple. Or imagine a boat, a ship that is moving from one port to the other one. This is a simple animation. You can do that easily in game engines. And also, um, shading and lighting is a really hard task because, again, there needs to be a lot of calculations. There if you have a light source, for instance, and you are moving this light source, such as you have a light at the front of your car. If your car is moving, then um, and if you're inside the car, then the world should be lightened while you are moving. The road should be lightened. But to calculate this in real life, you need to basically um, set some boundaries so that um, it will be possible to calculate um, the practical part of lighting um, with limited hardware, such as your computer. Um, because in real life, light bounces from all the walls. So it's and there are millions of light photons in real life. But luckily, Unity has ways, and other game engines also have ways to deal with that. And shading is the opposite of lighting, not opposite, but complementary to lighting. Shading means that um, when there's a shadow or a filter on top of something, you need to take that into account as well. Also, it takes care of networking, which is a problem mostly in multiplayer games, but not only for multiplayer games. So they, for instance, even if you have a single player game where you have a leaderboard, then you need to have some communication with the server, etc. Okay, and also physics is something you need to take care of. For instance, there is gravity in most of the games, and um, this is a um, ex- what was that? Um, what was ivme? Acceleration? Yeah, acceleration in um, drawing force of the world. So there are some game objects that are affected by uh, this pulling force, uh, and there are some game forces that are unaffected by this force. So you need to take this into account. And uh, you have talked about AI, and uh, some of those AI features are already in game engines, so you can use them freely. And yeah, level editor is another problem. You need to jump from one level to another without um, uh, without losing the um, statistics that you have in your character. So you need to take your character and move it to another level. And also there are some custom tools that are offered by different game engines. Here you can see different game engine logos. Um, CryEngine is a popular one that is talked about in game developments. It's made by Turkish people living in Germany, um, and Unity and Unreal are the dominating um, engines currently. Okay, um, let's go further. Uh, Let me just check that. Oh, okay. Yeah, since the lecture's name is pipeline, maybe we need to um, mention this briefly. So, games are multimedia applications by nature. So, by multimedia, we have um, sounds, visual effects, visual um, assets, and animations. And there's also some code that is running as well. So it's actually, if we exclude the coding parts, it's really similar to a movie. And because of that, to create a full game, you need to have um, an you need to have an art team, and you need to uh, have some visual artists and sound artists, and all these assets, um, all the things that they produce should come together to create a game. And this is called actually a pipeline, game development pipeline. So um, this is the um, this is one of the things that we should worry about when you are using an engine. How are you going to uh, add different um, assets into your game? Okay, so this is an example of a pipeline. There are some artists that um, use Photoshop and create a plugin. Sorry, uh, they use Photoshop and create some art, and this is transported to our compiler via a plugin. So for different file types, like XSF or FBX is another common type. um, that is used in 3ds Max. You basically have plugins that let them um, be converted to a type that is understandable by your game engine. So this is some example from CryEngine. Um, so it's this CryEngine basically gets different assets from different art studios, such as Photoshop, Autodesk Maya, 3ds Max, Blender, etc., etc. Um, okay, we have talked about assets, but what we mean by assets is models, textures, sounds, videos, and animations. Textures are the things that go on top of models, but you probably know that, right, from uh, 3D modeling class, right? Okay, great.
Yes.
Um, we have talked about all of those, so let's move forward. Okay. There's a hierarchy in every scene. You basically, I mean, some objects locations are depending on other objects, such as if there's a necklace that you have added on top of your character, this necklace will be carried with your character. Or if you have a sword, let's say that your character's name is Arthur, okay, and somehow he managed to pull the impossible sword from the rock, and after that the game goes on, and this Arthur basically slays opponents. In this case, the you need to um, put this sword inside the hands of Arthur, so he can carry the sword wherever he goes to. So this creates a hierarchy. You don't move the sword and Arthur separately. The placement of the swords um, changes according to where Arthur is. Okay. So this creates a hierarchy. In this case, character A has hats and glasses, etc., etc. And this is a logical arrangement. There's also a spatial arrangement. So if there are two different characters, then you need to specialize the location of each character. Um, in Unity, we use a hierarchical structure. So it's like a tree. Um, but I believe in some games there are graph structures. So they, I mean, some entities can be affected by more than one other game objects. Okay. Uh, we have talked about rendering, and there's a render engine inside Unity and other engines as well. And this is usually built on OpenGL. OpenGL basically uses C++. I'm not sure about DirectX, but OpenGL uses C++ to manipulate each pixel in the screen. And you need to know some matrices, basically. Uh, these render engines generate images in real time from assets. It's controlled by the scene graph, which is the hierarchy that we have talked about. And they interact directly with the GPU. GPU basically means graphical processing unit, or ekran kartı in Turkish. And this means, the architecture of a GPU is basically small CPUs, small that are small sized, and that are responsible for each pixel in your scene. So I mean, it's generally is a mixture of small but many CPUs, and they are responsible for a pixel each, or I mean, roughly. Okay, we will going to have a break and we will continue after 10 minutes maybe.